Hello everyone, this is Smudge8 here. This is a presentation I made for my physics class, so it's just going to be a simple PowerPoint. I didn't really have time to do a bunch of nice editing like I would normally want to do, but I hope you still enjoy it. I am a huge kaiju fan. Godzilla vs. Kong is my favorite anything I've watched this year. It was amazing. So that's going to be the focus of my project. However, I'm not going to do the obvious thing and explain why kaiju are just too big to biologically exist. Rather, I'd like to investigate some of the consequences of assuming such creatures could exist as presented in this movie. Specifically, I have one question. How much energy was stored in Kong's axe when it exploded? How much energy would the axe have to output in order to fling both Godzilla and Kong the way it did? Along the way, I'm also going to investigate several other questions, including how much does Kong weigh, how powerful is Godzilla's atomic breath, and how long would it take Godzilla to actually blast a hole down to the hollow earth? Now, I'm going to be making a lot of assumptions in this. This is what I like to call napkin math, where it's like just some quick, dirty calculations to get a rough estimate, and a lot of the numbers that we're going to be using are going to be really big anyways. Cutting a few corners doesn't hurt as bad, but as I'm going, I'll make sure to explain what I'm excluding, and usually it comes down to simplicity. Now, calculating how powerful the explosion is should actually be really simple. An explosion is an increase in kinetic energy without a change in momentum. So, I simply need to calculate the initial and final kinetic energies with this conservation of energy equation. However, since Godzilla is still anding still initially, we can remove his initial kinetic energy. So this gives us the initial kinetic energy of Kong will be equal to the final kinetic energy of Kong plus the kinetic energy of Godzilla minus the work done by the explosion. Now, finding velocity. This was probably the hardest part of the project because I have never done pixel measurements before, but I had a lot of fun with it. To do this, I first got some reference images, if that's what you're seeing on the screen right now. I took their Canon heights, and using that, I found how many pixels was a meter, and then using those pixels per meter, I measured other parts of their bodies so that I could more easily measure them in other scenes, because like when Kong's jumping or getting flung back, he's not exactly in a position where I can measure his full height. And when Godzilla gets knocked back, it's just showing his upper torso. So for these scenes, I measured using Kong's forearm, and then in the one scene with Godzilla, I measured the distance between his eye and his nostril. And as I talked about with like pixels to meters and stuff, using these distances, I had to create unique conversion factors for each shot I used. In order to figure out the initial and final velocities, I needed to take screenshots of important moments, measure how much distance was changed, and time how long it took for that distance to be covered. In most of these scenes, the camera is actually what's doing most of the moving. The kaiju just kind of stays in place relative to the frame and everything moves around it. So I actually would choose something else besides the creature that's stationary to measure. So for instance, for Kong's jump, since Godzilla's standing still, I actually measured it based off of him. And then when the kaiju get knocked back, I would choose a nearby building in the background to measure the movement for. And it is worth noting at this point that technically there should be more to this, but I'm boiling it down to one dimension because judging depth here is really hard. And also the motion in the Y direction doesn't really matter that much for what I'm trying to calculate. The speeds I ended up with are as follows. Kong's initial velocity was 53 meters per second. Kong's final velocity was 84 meters per second, which is actually greater than he came in with, and that is going to cause us some problems down the line. And Godzilla's final velocity was 35 meters per second. Now, I was able to find cannon heights for Kong and Godzilla's cannon weight was 99,000 tons or 90,386,000 kilograms. I have almost everything I need to calculate the power of explosion, except I'm missing the mass of Kong. I couldn't find a solid official thing on how much he weighed during the Godzilla vs. Kong movie, so instead, I decided I will calculate Kong's mass myself. In order to do this, I will treat the interaction as a collision, since that's what it would be without the explosion. Kong and Godzilla would just kind of smack into each other. The fact that it's an explosion just means that their kinetic energy after the collision is actually more than before the collision. However, their momentum should stay consistent from before and after the collision. So by balancing out their momentums, once again, Godzilla does not have any momentum initially because he has a velocity of 0 since he's standing still, and we can rearrange it to solve for the mass of Kong. Now this is where Kong's increase in speed after the explosion bites us back in the butt. Using this formula, we get a mass of 292 billion kilograms, or 322 million tons. That is half the weight of the asteroid Bennu, pictured here, which has a diameter of 4 times the height of Kong. Kaiju are already incredibly heavy, but that much mass is just ridiculous. That would have all kinds of consequences. Now, I was able to find an unofficial source saying that Kong weighs about 50,000 tons, so for the rest of this presentation I'm going to address both options since they both yield interesting conclusions. So then, how strong was the explosion? If the energy equation for this scene is this equation that I mentioned earlier, and kinetic energy is 1/2 mass times velocity squared, we can sub that in and solve for work to get this equation, which I struggle to figure out how to say that properly, but it's basically Godzilla's change in velocity times Godzilla's mass plus Kong's change in velocity squared times Kong's mass. Both velocities are squared, I forgot to mention that, times 1/2. Now, if we use our pseudo-cannon weight, I'll refer to it as the given weight for Kong for the rest of this presentation, we get an explosive output of 9 trillion joules, which is about 2,000 tons of TNT all set off at once. Now, we know that how powerful the explosion was. We can calculate the power energy output of Godzilla's atomic breath. We know the axe got charged up by the power source in the hollow earth. However, once again, for simplicity's sake, we don't know how much power that contributed to the axe, so we're going to treat it as if all of the axe's power was from Godzilla's breath. So this would be an absolute maximum estimate. Watching the film, the axe spends about 10 seconds absorbing Godzilla's atomic breath. So that would mean Godzilla outputs 919 billion joules of energy in 1 second. That's 200 tons of TNT every second. However, let's back up a little bit and start again. If we do the same calculation for our ridiculous mathematic weight for Kong that we calculated earlier, the explosion outputs 1.24 times 10 to the 15 joules, or 297 kilograms. That's 297,000 grams of TNT, which is equal to 14 times the Fat Man, the bomb dropped on Hiroshima. The power of this explosion has increased by 100 times. This means that every second, Godzilla outputs 124 trillion joules of energy. In other words, every second, Godzilla spits out a Fat Man bomb. Now, given our calculations on how powerful Godzilla's breath is, even the smaller one is a ridiculously large number, and we kind of need a way of comparing it. Thankfully, I figured out another scene which we can use to do so. Pretty intense, huh? So my plan is to calculate how much energy it would take for Godzilla to blast that hole, and then calculate with our two different values for the strength of his breath, how long it would take him to make that hole. The first assumption I'm going to make is that since Kong can comfortably jump through, it's at least twice as wide as him, so I'm going to treat it as if it has a radius equal to Kong's shoulder width, which once again I calculated using one of the reference images from earlier in the presentation. The hole appears to be roughly the same all the way through, so it's essentially a really long cylinder. So we can take this equation, which is the volume of a cylinder, pi times r squared times height, and to find our height, we do get a quote in the movie. Right before they follow Kong into the Hollow Earth, one of the scientists says that they're about to travel 1,000 miles in 2 seconds. Now, as far as going 1,000 miles into the Earth, that's not actually sort of believable, because the Earth's radius is actually 4,000 miles. So you're only a fourth of the way as far down as you could go to get to the center of the Earth. Anyway, 1,000 miles converts to 1,609 kilometers. Convert this to meters and plug it into our cylindrical volume equation, we get a volume of 181 million meters cubed of rock. Now, I specifically want to phrase this as the rock getting vaporized, because other than a small blast of magma once Godzilla's atomic breath ended, the hole is completely devoid of any sort of matter other than air. And the rock had to go somewhere, so if it seems to have completely disappeared, it was probably vaporized. Here's a table I found showing the energy required to vaporize various types of rock. For simplicity and a good average, I'll assume that the entire space between was made of granite. In order to vaporize this much granite, it would take 4.97 times 10 to the 15 joules of energy. Knowing that much energy, how long would it take Godzilla to dig that hole? If we use the lesser R2 value, so the one with the Kong being the given weight, not the mathematically calculated weight, Godzilla's breath is strong enough to do it in 5,414 seconds, or about an hour and a half. If this was what happened, then they had plenty of time to evacuate everyone out of Hong Kong before the big fight took place, which they clearly didn't, because there are scenes of people in the building as they're fighting. Let's backtrack a little bit. If Kong's mass is such that momentum is conserved, so that's our ridiculous asteroid-sized mass, then Godzilla could make that hole in only 40 seconds, because his breath is that much dramatically more powerful. Interestingly enough, in the movie, it appears to take Godzilla only about 30 seconds to dig the hole, meaning that this estimate is actually pretty close. In conclusion, since momentum must always be conserved, if Godzilla bored a 1,000-mile deep hole in 40 seconds, that would prove that his atomic breath provides enough energy to compensate for Kong's ridiculous mass, meaning Kong weighs 3,000 times more than Godzilla. Thank you for watching. Make it a great day.